Right now, there are more than 1,000 thunderstorms happening on Earth. Some 6,000 flashes of lightning will occur in the next minute. That lightning can be devastating, especially to tall structures. That's why NASA is taking steps to protect its most valuable assets. And it's doing so with an innovative new strategy. Learn the secret to NASA's Launch Pad Lightning Protection System, next on Real World. Whoa! Thunderstorms and lightning can be some pretty scary stuff. And I'm just standing in front of a green screen video effect wall. Imagine if I was actually outside in the middle of a thunderstorm. Well, NASA's next generation space exploration vehicles aren't going to be able to avoid being in the middle of some potentially dangerous storms. Launch Complex 39 at the Kennedy Space Center in Florida is the site where the Ares 1 and Ares 5 rockets will launch from, taking crew and cargo to the moon and beyond. And lightning is a well-known danger in that part of Florida. So scientists and engineers have been hard at work designing a new lightning protection system that's above and beyond any the Space Center has ever seen.
There's a better method called rolling spheres.
John Cowart is the Ares 1X Deputy Mission Manager.
For the past 50 years, the way people have done lightning protection was using this thing called the cone of protection.
The cone of protection was used by NASA on the Apollo program and is pretty common beyond NASA. It's the basis behind the lightning rod. A fixed rod or mast is built high into the air, creating a cone of safety. In theory, the height of the tower equals the radius of the base of the cone, inside of which is relatively safe from the lightning. You can find examples of this type of shielding on top of roofs, water towers, barns, silos, just about everywhere. It is pretty efficient for buildings, but with so much at stake, NASA needs something better. They upgraded for the shuttle system, with a single lightning mast on top of the structure with two curved wires, called catenary wires, going to the ground. Catenary wires can help divert lightning strikes, but that upgraded system still has its problems.
You don't want what we call a direct attachment. If the lightning bolt hits the wire like it's supposed to and travels down into the ground, you still get a huge electromagnetic pulse. But that pulse is much less than the one you would get if it actually got a lot closer to the vehicle and hit a fixed service structure or even attached itself to the vehicle.
The energy from a lightning bolt can be hotter than the sun and can fry valuable electronics. To explain it better, we check in with Richard Biles from the Virginia Air and Space Center.
Lightning is a discharge from cumulonimbus clouds. The clouds develop a charge when the particles of water and ice in the cloud roll through, when the bottoms become generally positive and the tops become generally negative. And of course, if you've got negative charges at the top and positive charges at the bottom, they try to get to each other. And as the cloud moves across the landscape, it also imparts that positive charge to the ground underneath it. And so what happens with lightning is it comes down through the cloud and then right to the ground. And of course, it always tries to find the tallest thing.
But the rolling sphere system will significantly increase the shielding level and further separate the electrical current from the important hardware.
Rolling spheres, which gives you much better protection. Those three towers will actually have wires coming towards the middle, right above the pad. They will form into a nice little opening that the vehicle can fly through. It gives you much better lightning protection than what shuttle has had all these years. As the positive and negative electrons begin to build up, the wires and the mast itself will actually create an easier path for the lightning to get to ground. The wire actually acts as a conductor. The lightning will pass into it, go out to the wires, and then it travels back down to the ground in order to dissipate that huge electromagnetic energy.
The system features towers more than 150 meters tall with an additional 30-meter fiberglass mast atop each one, supporting the wire catenary system. It also has 216 pilings extending down 15 meters below ground. The massive steel towers were partially assembled horizontally on the ground, and then lifted into the vertical position by a 60-story tall crane. The first Constellation vehicle, the Ares 1X test rocket, will take off from Launch Pad 39B in 2009.